everyone. A very good evening to everybody present here. I hope you all are doing great and staying healthy. My name is Srishti Vadhera and I will be your host for this session. I wholeheartedly invite you all today to the first pre-hackathon speaker sessions at hackCBS 4.0. Proceeding with the tradition of our seniors, with much dignity and confidence, we take the lead to arrange the fourth version of hackCBS, which is India's largest student run hackathon. Utilizing the advanced time zone this year at hackCBS 4.0, we will have loads of speaker sessions consistently. To know the nitty-gritty timetable, you can even look at our website, that is hackcbs.tech. Along these lines, we desire to make these sessions a noteworthy and sagacious experience for all of you. So let us start with our much anticipated sessions. Now, talking about today's session, this session will be about Polkadot and building with Substrate 101. Blockchain is the new buzzword in town, and we are here with an informative and interesting session which will help you get hands on experience on building a blockchain and customizing its runtime logic, all on a browser. With that said, let me introduce you all to the speaker of this session, Radhakrishna Dasari. Radhakrishna is a course developer at UBTCIE, lecturer of computer science at University of Vermont, and a technical educator at Web3 Foundation. We invite you, Radhakrishna, and anticipate your discussion. The virtual stage is all yours.
Thank you. Can you hear me?
Yeah, we can hear you.
Perfect. So thank you very much for that warm welcome. I have 1 hour to talk about like Polkadot and Substrate. I'll try to do my best. So today's session is also going to be a kind of a hands-on session. So we'll get to that when we, move into the middle of the presentation. But for now, let me just start by sharing my screen. Okay, so my target in today's session is to give you a broad overview of what Polkadot is and give you a glimpse of how it is to build with Substrate. So let's talk about the vision of Polkadot. Okay, so this is a broad vision, an ambitious vision, if you keenly look at what we are talking about. So we're talking about fair, secure, and resilient web that protects user interest by design. These are like big challenges. As you can see, there's a lot of objective. So how do you define these like objectively and then be able to achieve them with technology? So that is what we at Web3 Foundation and Polkadot are striving for. So the tagline is less trust and more truth. So you need not trust anybody and then still have access to a lot of truth. So the 2 key organizations that are behind Polkadot are Web3 Foundation, which is where I'm from. We're about like 50 employees, a lot of research going on here. And then the developers of Polkadot are mainly from Parity. So Parity is based in like Berlin. So they are about like 150 dedicated employees who are working on Polkadot. So if you look at the Polkadot, Polkadot is a blockchain, and here is the link. You can just, type this out in the browser, and then you'll be seeing this interface. So what we are looking at here is, there are about 7 million blocks that are already up there, and then every 6 seconds, a new block is being added. Okay, so you have these entities, which we call validators. So these are the ones that are creating the block and adding it to the blockchain. So Polkadot is inflationary. So the tokens of Polkadot are dots. So there are over 1 billion dots in circulation. We'll talk about this when I get to how the Polkadot network is secured. But anyway, so if you're curious, I'm just gonna show you like the the network in live. So if you have this open, so you can see that there are a lot of events that are happening here. Okay, so there are balances going from one account to the other. So all of those are noted right there, and you can examine like any individual block, and the transactions through the interface here. So this is based on like JavaScript. As you'll see later on, this is like the front end that is available for you to interact with even like Substrate based chains. So there's a lot going on. So you have staking, through which like the network sort of secures the whole network. So if you take a look at it, these are all the validators or the nodes that are running right now, who are like securing the network. And then if you're interested in like visualizing the nodes that are out there in Polkadot network, so telemetry.polkadot.io. So that's the website to go. So it clearly shows you a very good visualization of all the nodes that are, currently securing the network, or even, acting as a full node, letting others access the blockchain network. And this website also like hosts a bunch of other blockchains that are developed on Polkadot ecosystem. So I definitely recommend checking this out if you're interested in developing on Polkadot. Okay, so what is the technology that powers Polkadot, right? So most of you, or I think all of you, are into development. So this is a hackathon, so I'm assuming so you delve deeper into the technology. So Polkadot is built on Substrate. Shortly, you'll see what Substrate is and what you can do with Substrate. But take a look at all the existing projects that are already there that are using Substrate, right? So pick any hot topic in like blockchain space. You'll see that there are already projects that are existing on Substrate, and most of them are open. Like all of the code base is open for you to check out. So if any of these areas interest you, I would suggest go check out like those project GitHub repos. So that's going to give you a good understanding of how they're leveraging the features of Substrate and building such blockchain applications. So talking about Polkadot, so I've given a vision statement for Polkadot. I told you how it is built, but what exactly is Polkadot, and how does it facilitate so many blockchains to work together seamlessly? So the idea is that Polkadot is a layer 0 blockchain. Okay, so if you're familiar with blockchain terminology, you would have heard that Ethereum and Bitcoin are layer 1 blockchains. So anything that is built on layer 1 blockchain is layer 2. So clearly you see such blockchains on Ethereum. So there are plenty of blockchains that are built over Ethereum. So now we are talking about a layer 0 blockchain where this is Polkadot, and then these can be a Bitcoin, can be an Ethereum chain, can be any other application chains that I've shown you in the earlier slide. So we're talking about a relay chain. Okay, so this will be Polkadot. It will be facilitating the block productions of all these parachains, and then help them like secure using the validators that are there on the relay chain. And it will also help those blockchains communicate with each other without the need for building bridges. Okay, so any parachain here can communicate with the other one seamlessly through the relay chain. So there is the concept of para threads. It's not implemented in code yet. The idea is that all these parachains have to win a slot to be on the relay chain. So being a para thread, you'll be able to connect to it whenever you would like to. So more on that like later, but this should fairly give you the idea of where exactly Polkadot stands in the blockchain space. So going a little bit deep into the network architecture, so we're talking about a scalable interoperable and secure network protocol, right? So so all of those are ensured with the architecture that I have on the slide. So you have a bunch of parachains, and then if you would like to connect to blockchains from different ecosystems, you can like develop bridges for it. As you can already see in the GitHub repos of Substrate, so there are actively a lot of bridges being built to bridge blockchains from Ethereum and other ecosystems. And so we'll not go much into the detail of the architecture itself. So think of collators as these nodes that are going to submit blocks to the relay chain to finalize them. Okay. Yeah, so this is pretty much the overview of Polkadot architecture. And as you can see, I'm wearing a Kusama t-shirt right here. So Kusama is indispensable from like Polkadot. So both of them go together. You can see that both Kusama and Polkadot are independent. Okay, so a better way is for me to show it in live. So if you go to Polkadot.js, so you can see this interface where you see Kusama as well. So I'm gonna go and then switch to this particular blockchain. So what I'm doing right now is changing the RPC connection. Okay, so I'm connecting to a full Kusama node offered by any of these entities. So I'm just going to switch right there and show you like what I can see. So what we're trying to do right now is we're going to take a look at the parameters on Kusama network. So once it initializes this connection, I should be able to see it. All right. So as close this. So earlier on Polkadot, you would have seen that this is 24 hours, meaning an era. So era is when all these validators are selected, and a lot of network parameters are reset after one era. So in Polkadot, it's 24 hours, but on Kusama, it's just 6 hours. And this is basically on purpose. So if I go to the Network Explorer, so you can also see that Polkadot has lesser number of validators than Kusama. So all this is based on design. So Kusama is meant to be a canary network for Polkadot. So if you're a developer and then you're trying to put your application on Polkadot, it is important that you test it out in a real world scenario, and that is what like Kusama offers. So pretty much it's almost the same. So you see that there are 9 million blocks in Kusama, and already so many projects have been onboarded as parachains, or at least registered as parachains on Kusama network, and slowly you'll start seeing all of them moving to Polkadot, right? So Polkadot doesn't have parachains yet, so that is something that is ongoing right now. So with that, I'm just going to talk more about Kusama. So as a developer, you would want to innovate. You would want to break things to know what kind of code is unbreakable, right? So all of the testing is done on Kusama with some real world economic value attached to it. So both of them are independent. Both of them have their own individual governance. So governance is another big feature of Polkadot, where you have democracy, where everybody owns the tokens, like dots and Kusama tokens are allowed to have a say in what happens on the network, right? So, and talking about like testing, like again, I told you Kusama has an economic value, but if you would want to test out things without having to face some, losses, Polkadot offers that too. So there are a bunch of test nets that you as a developer have access to. So Westend is a blockchain again, which will have the same code as Polkadot. So if your application works very well on Westend, you might be confident that it will work well in terms of code on Polkadot very well. Okay. So there are a bunch of other test nets too, like Canvas. It supports like smart contracts. and Rococo. This is being revamped. Here is where you'll check how your project plugs into the relay chain as a parachain. So parachain means parallel chain, right? So these chains are running in parallel to the relay chain, and they're being plugged into Polkadot and Kusama. Okay, so I'll spend little time on explaining what Polkadot is. We'll dive right into the hands-on with Substrate pretty soon. But here are the key features that I want to highlight about Polkadot. So it connects the networks together. Let's see how it it can be visualized. Okay, so you have Bitcoin, which is a blockchain that is destined to do one thing, right? So it's a distributed ledger of all the transactions that are happening, in the Bitcoin network. So that is a layer one blockchain, and then you have Ethereum, which is another layer one blockchain, but it is capable of doing much more. Okay, so you can have applications run on top of it. Now you can visualize all of these as parachains on Polkadot. So currently, like Polkadot supports about like 100 parachains. So basically, the architecture's limit is that, and things are being tested out on Kusama right now. There are plans to expand like Polkadot, into a nested version where you can scale it to, you know, a lot of parachains, but that is in the future. For now, we're talking about like 100 blockchains in which like individual blockchains could be like Ethereum or Bitcoin or any other layer one solution that you're looking at. So we're talking about a big blockchain ecosystem that is being secured by the security provided by the Polkadot validators, and it all of them are interconnected to each other using the relay chain logic. Yeah, and then also there could be parachains that bridge the Polkadot ecosystem, this 100 blockchain ecosystem with other ecosystems, and those will be the bridges. And there is also plan to bridge, the Kusama relay chain that I talked about, which is the Canary network with Polkadot. So all of this is really exciting, and all of this code is available online. So if you're interested to see how the developers are doing all this, everything is very transparent. You should be able to check the updates every day. All right, so enables custom-made platforms to be built for specific apps. Okay, so you as a blockchain developer set your own parameters, right? So you want your transactions to be finalized faster, or you're only interested in developing the application logic of your blockchain and don't worry about any other parameters like how the nodes are reaching the consensus or how the finality is happening, etc. So Substrate is going to provide such interface for you, right? So if you're a DJ and then you're in a party adjusting like the music to the song, you have these bunch of uh, buttons that you play around with and then customize it to that specific song, right? So Substrate offers such platform for you to work with blockchains. And yeah, so it handles heavy traffic at scale. So I already talked about Polkadot relay chain supporting 100 parachains. So there was thorough testing and benchmarking done on the current logic. As you can see, for 3-second blocks, we were able to achieve about 4,500 transactions, like heterogeneous transactions happening on the relay chain. So that's about like 1,500 transactions per second on the relay chain. Now, because the parachains also run in parallel to the relay chain, so we're talking about 100 times 1,500, and based on some optimizations, you can achieve a transaction speed of this scale across the whole ecosystem. So if that makes sense, but yeah, so fair comparison is with like Visa, which is like a centralized um, transaction entity, validating an entity, so they are capable of doing so much. Okay, so let's talk about governance, which is like a really interesting part of Polkadot. Some chains don't have any governance. Okay, so and some chains might have like few people who decide what happens with the network. So if they want to just revert to a certain block, in time they could be doing it because they have the pseudo access on the entire blockchain. So even when you as a developer, when you're developing a blockchain, so initially the access will be pseudo, so you as a developer have full access on what the network does. And this is what Polkadot does right now. It is the community, right? So it's the community who votes on what happens to the network, including network upgrades, any changes to the network parameters. All of those have to be like voted by the community. Yeah, so there are a lot of exciting things that you can do. As you can see, like Polkadot as a democracy, where every dot holder has access to all of these. Okay, so you can propose new things like referenda. You can vote on referenda. You can vote on council members who will represent you in like deciding like which of the proposals should be having more spotlight, etc. And the same Polkadot.js interface. So if you go to the governance tab, so you'll be seeing all these. Okay, so there's democracy where you get to like vote. So there are like bounties, like if the Polkadot community decides there's something important to be done, so they can like create these bounties so that developers can create that feature and then give it to like the Polkadot network. Yeah, so here is the interesting thing. So when somebody proposes something on Polkadot, it's not just like a proposal. There is also an associated code or a bunch of parameters with that proposal. So once that proposal is voted, the entire code is going to be deployed to the Polkadot network, and it sort of upgrades the network. So that's really interesting. So you're basically porting the software along with the proposal. So once it is voted upon, it'll directly be merged to the Polkadot network code. Yeah. So and then leading security, like how does Polkadot offer security to all the parachains? It is through the validators on the relay chain. So validators are the one that create blocks, right? Uh, so such security is offered by nominated proof of stake. So Polkadot has one of the sophisticated nominated proof of stake systems that are out there. If you're interested, like check it out, like how we do, this nominated proof of stake, how we match like nominators, their dots or Kusama with the respective like validators. So there's a lot of thought put into this mechanism. This is still, we can't claim that it is flawless or it converges to a full decentralization. But if you think of decentralization as the ideal, circle, we are getting there, with this, and lots of improvements are in plan on this technique as well. And finally, here's the interesting part. So self-upgrade. So think of, something like this. So you created this when you're a blockchain developer. So if you start building a blockchain, so this is what you release, and then you can't let this be the only thing that runs throughout your blockchain's lifetime, right? So you want to be able to customize it and change from this to this if you would like to. So that is what like Polkadot offers. So conventional like blockchain upgrades like Ethereum, Bitcoin, they look like this. So there is block production happening. At this point, a significant part of the network decided that this is the canonical chain, and then they keep adding blocks here, and then the other half or a significant part of the network decides like this is the canonical chain. Now, these splits have happened in Bitcoin as well as Ethereum community, but Polkadot solves this, right? So the way it solves it is the code upgrades are done on the network, and the code of the network, like the core logic, is also ported with the block. Uh, so it's not just like a property of the node. So the code itself with which these blocks have to be produced, they are placed on the block. It's very interesting. So check out forkless upgrades. So there is no scope for forking on Polkadot network due to this property. And how are these changes made? They're made through like the governance. Yeah, so if you're following the space closely, Polkadot has announced like parachains, the auctions. So they're going to be starting like next month, November 11th. But yeah, so the announcement was made on October 13th. So this presentation is very relevant to what's going on in the Polkadot ecosystem. Yeah, so you'll slowly start to see like all the parachains on Kusama move to Polkadot and then deliver enterprise level applications. And I'm going to close off my discussion. Let me see how I'm doing with time. Yeah, so I'm going to close off the discussion about Polkadot by talking about future upgrades. Okay, so the cross-chain communication that I talked about, so that protocol is still being finalized. So now the parachains can talk to each other, but we want much more like refined way of communication. So that is facilitated by XCM, which is cross-chain communication. All right, so let's get to the development and the hacking aspect of Polkadot, Substrate, and everything in the ecosystem. So I'm gonna share with you, the presentation I made for Sub-Zero. So if you attended that conference, you would have participated in this workshop. But now is the chance if you missed out on those. So let's see how you today can build a blockchain on your own and then add some kind of customized logic to it. Okay, so I talked about this already. Substrate is a modular, flexible, and extensible framework for building blockchains. So modular meaning you can take a look at the code and then see how modular it is. Like every module is destined to do a certain thing. So if let's say you're talking about staking. So if your blockchain needs to implement staking, so you can go to the staking module or staking palette, that's what we call it, and check all the logic that is being implemented in there. So it is flexible, so you're free to choose one module over the other. So there are a bunch of modules available for the same, um, you know, same functionality. So for instance, there is a proof of stake module, there is a proof of work module. So depending on what you want in your blockchain, you're free to like select that. It is extensible framework. Okay, so today you can start taking a look at all the modules and you feel like something can be extended or something new can be created. You're free to start developing on that and then extend what is already there in Substrate. And all of these modules, they are battle tested, meaning lots of developers have put a lot of thought process in building those modules, and all of them are working like plug and play devices. So of all the modules that you see in Substrate repo, so there are specific modules which belong to what we call frame. So frame stands for Framework for Runtime Aggregation of Modularized Entities. In simple words, so we're talking about the blockchain runtime logic, right? So you want your blockchain to do a specific thing. So these are the modules that will let you customize that kind of logic. So like I said, we call them like palettes. So you're going to work with one of those palettes in today's session. So here is a figure that shows you the kind of technical freedom that you get. So Substrate repository ships with a Substrate node. So this is like a fully functional node out of the box. Okay, so it has a consensus protocol. Um, so you can just spin it up and then it starts like working out of the box. So you can either start here or go a little bit deeper. So you can make changes to the Substrate frame palettes, or you can also change the core primitives of Substrate, right? So at the very core level, you have full customization to change like what happens with Substrate. But yeah, so for most of you, I'm thinking today is the first time you're seeing Substrate. So we're going to start right here. Okay, so this is the most easier way to get started with development on Substrate. Yeah, so Substrate, developing with Substrate is looks like this. So you're just going to pick and choose the palettes that are already available for you, and then you put them in the runtime. So here are a bunch of palettes. So sudo palette gives you like the sudo access on everything that happens with the blockchain. So balances palette, as you'll see, is going to enable like accounts right off the bat, and then currency and transactions. So you don't have to implement that separately. So you have everything shipped with this. So there's a staking palette if you'd like to make your network like work with like proof of stake, and so on and so forth. So Aura is for block production. Yeah, Babe is for block production as well. So today's agenda. So I'm going to briefly show you what this substrate node actually contains. We're going to work with this substrate node template, and then I'll walk you through a typical palette, like the code. Um, Once again, like if you're new to this, so we use a programming language called as Rust. So you don't have to understand like what I show. I'll just show you a high-level skeleton structure of a palette. And finally, how you can put all of these together and innovate, like create your own blockchain product. So here is the anatomy of Substrate node. We have at the lower level, we have the lib P2P, peer-to-peer. So that's how the node connects to the other nodes in the network. So consensus, like how do these nodes agree that this is the finalized block in the blockchain? So that technology is given by Grandpa. So it's developed by the researchers at Web3 Foundation. So lib peer-to-peer is the networking protocol. So this is not developed here. So if you're aware of IPFS, so the developers of IPFS are the ones who created this networking stack as well. Yeah. So Substrate node ships with libp2p and the consensus protocol called Grandpa, and then WASM. So WebAssembly is the next big thing in blockchain space, because if you're not aware of it, just Google like WebAssembly. Okay, so you'll see there's a lot of interesting developments in that space. So basically, WebAssembly lets you like run the programs on a browser, right? So you're talking about running like light clients. Right now, all the blockchain nodes use a lot of resources on the computer. So we're slowly shifting to running these light clients, right? So Substrate is futuristic in that way. So all the runtime logic is run on like WebAssembly. So to give you a brief overview of the anatomy in terms of like how things interact with each other, earlier when I was connecting to Polkadot.js, so I was making this RPC connection to the remote node, right? So when it's like displaying all the blocks, the transactions and everything, it's basically getting all the information from here. So through this same like node, I should be able to like transfer my dots to a different account. So that transaction is noted down in the transaction pool. Again, like all of those have to be like communicated with other nodes in the network as well. And everything comes to a consensus, and then the finalized block is sort of created. So here is the tricky part. Like this can create this block and then send it to every other node if this is like a validator. If not, it will get that block from the RPC server connection, and then it adds to it right there. So the executor is at the heart of all of this process. So this is going to dispatch any sort of non-runtime commands. Like these commands can come from the node itself. So it's going to take care of all of that. And finally, telemetry. So I showed you Polkadot telemetry, where every node in the network can be visualized at that website, right? So telemetry is going to give the node metrics of this and then show it in a single interface. Okay, so today we're going to take a look at the Substrate template node, the node that we give you out of the box to run and build your own blockchain. So it has pseudo governance, and then you should be able to like easily add and remove palettes from it, and then create your own customized modules if you'd like to. So So this is the browser-based, Substrate development environment that I was talking about. So go ahead and then click, open this link in your browser, and I'll also ask the moderators to share the workshop link if they haven't shared it already. So that should have like all the instructions to do this in real time along with me. Okay, so this is the link which has all the instructions, and then I want everybody to go till here, and then I'm gonna demonstrate like what exactly happens with the Substrate playground. So I'm gonna give you a couple of minutes for everybody to set this up, and then I'm gonna stop screen share. So if the discussion is happening in Discord, I'm just gonna go to Discord and see anything that's going on. Okay, in the interest of time, I will go ahead with what I have. All right. So all you need is a GitHub account. And then once you click on the Substrate playground, so you're just going to have to like log in. I'm going to log in. Okay, so I hope everybody caught up with me here. So there are a bunch of templates for you to like, experiment with. So in this workshop, we're going to take a look at the node template. So as you can see, the node template offers a skeleton blockchain. It includes like peer-to-peer networking, which I talked about, consensus, like finalizing the blocks, finality, account transaction, and so on and so forth. So all of these palettes are included, and let's see this in action. I'm going to click on create. Okay, so here is the blockchain that was spun up, and then it's running successfully. So let me go over a few of these details. So here, this is the binary which I'm running with a WebSocket external connection. So I'll talk about it in a bit. So as you can see, the block production has already started. So blockchain works this way, right? So you have a hash of a block. So this will be included in the next block. So you can see that, so the parent hash is this one, and the parent hash has been included in the next block. And basically this block production is pre-sealed. Like all of these blocks, they don't have any data. All of that is pre-sealed, and then these blocks are getting added to the blockchain. So if you're interested in visualizing this, through a front end, so go to Playground. I'm going to pause here. So everybody go to Playground, and then click on Open Polkadot.js apps. Okay, so basically this is the front end that is connected to the Playground instance. So as you can see, it connected to my specific like playground right there, and you can also customize that endpoint. So if you're developing this like locally, so you can always change this to localhost, and that's going to take care, of that connection. So already like around 17 blocks have been produced, and if you're you as a developer, if you're interested to see like what's happening in the blockchain, or what kind of functionalities your blockchain has, you can go to let's go to extrinsics. So extrinsics or chain state. So chain state shows you like all the palettes that were already included. So you have balances, which enables like accounts. So grandpa is for like blockchain finality. So you have sudo giving you like sudo access to whatever happens in the blockchain. And then template module. I'll show you in a bit where this code is. So this is the module that you can modify the way you want. Whatever blockchain logic you want to include, you can include it in that, and so on and so forth. So by default, like this template node comes with all these predefined accounts. You are free to like add a new account and then start interacting with these accounts if you'd like to. So without further ado, I'm gonna go to the node template again, and I'll zoom this a little bit so that everything looks better when it is streamed. So what I'm going to do is I'll stop the blockchain production. Right there, I click Control C, and I'll open the code that is shipped with this blockchain node. So let me see. All right. So I hope everybody is able to see like what's going on here. I'm going to briefly show you important things of this substrate node. Okay, so you have all these folders right off the bat. So I'm going to go and then open this node. Okay, so we're talking about the blockchain node here, and the chain spec file is the one that tells what happens in the blockchain at the genesis. So right at the beginning, when the blockchain is starting, what are the kind of parameters that you want to include in it? So the chain spec has all those details. So as you can see, you want to have few accounts created right at the genesis block. So all of them are, uh, initialized like here. So we have Alice, Bob, and others right there, which I've shown you earlier in the Polkadot.js. Yeah, and then so you can have like two different specs. Okay, so you can have one for like the development blockchain, one for like a test net. You can name it anything. So you can have like different specifications specified here, and then once you uh, change the way you create the blockchain. So here I'm initializing it in the dev mode. Later on, I'll show you like where you can initialize it in the other modes. And yeah, so all that is initialized here. So CLI and command, so these are the files that take care of like the command line arguments. And the main thing here is the RPC and the service files. Okay, so in the RPC file, you're free to like include whatever you want, like the custom way in which like the front end can interact with your node. So that logic can be included right here. And then service, so this is like the service factory. So what are all the services that you want to see created and initialized once you start the node? So here you'll see the telemetry, the consensus, on finality, etc. And this is like a pretty big file. So if you're interested, take a look at that. So one good thing about this node is that you're able to see exactly where exactly the logic is, and it's very modular. All right, so let's talk about the adding new custom logic to this blockchain. So I'm going to go back to yep. So I hope everybody were able to visualize like what's happening with the blockchain using the front end right here. So this is an interesting thing. So what is blockchain if there is only one node running, right? So you want multiple nodes to talk to each other and then create the blockchain for you. So this has a lot of compile time. So that's why I'm not doing it a live demonstration of that today. But after today's session, feel free to like run these commands. You'll see like a multi-node blockchain creating blocks for you in synchrony. So this is something that you'll do like later. But for now, let me show you how easy it is to include a palette into the runtime logic. So for that, I'm gonna use what is called as a Nix palette. So Nix palette, okay, so this is the actual tutorial. If you're interested, you can go in depth over like what this is talking about. Um, so Nix palette, like the name suggests, is to add a nickname to your blockchain accounts on chain, right? So we're going to implement that particular functionality on the Substrate template, the blockchain ship with Substrate template node. Okay, let me do that for you. So all this is saying here is go to the runtime. So we're talking about the blockchain runtime logic. So you'll go to the runtime folder, and then you'll change contents in this cargo terminal file. So for those of you who are familiar with like package managers on other development platforms, so cargo terminal file is like a package manager or a dependency manager for Rust. So I'm adding, so Nix palette is already created by the developers. So all I'm doing is I'm adding that like a Lego block into my blockchain logic. So I'm going to copy over this code, and then I'll go to the runtime cargo terminal file. Okay, so let me navigate there. So runtime palette, in here, the cargo terminal file. Okay, so you can already see like it has dependencies set with other modules this blockchain is using. So you saw the palette balances earlier. I showed to you like grandpa and others. So it's almost like you include it here, and then you have access to all of its features. So what I'm going to do is I'll go till the end, and right here I'm going to copy. Okay, so I'm adding a dependency to this new palette. So by default, we want to disable the features. I'll talk to you in a bit why we are setting this as false. Just make sure the tag matches with the other ones so that everything can work in harmony. So I'm just going to change that right there. If you're following along with me, just make those changes. And then I want you to go to the next line I have here. As we have disabled the standard features by default, we want to include that somewhere, right? So we want to enable those standard features, and we're going to enable that within um, that block of code. So I'm going to copy this line of code. So in palette Nix, I want to add these standard features. So I'm going to go back, scroll down. So as you can see, all the standard features of individual palettes, they're enabled here. I'm just going to add it right there. Once again, like I'm trying to fit a lot of things into like this 1 hour workshop. I can go in depth as to like the structure of all of this, but as of now, I'm just showing you how easy it is to plug and play using Substrate. So this is all that is required to add Nix palette to the template node that you have. So I'm going to save this. This is saved. Now you have access to the Nix palette for the runtime, but in the runtime you have to tell exactly how the blockchain uses that code. So that is the focus of the next section in here. So in the runtime source code, you're going to ensure that it has like all of this code. Okay, so here you're setting some parameters saying if you want to reserve a nickname, you have to spend about like 100 tokens. The nickname should have like minimum length of 8. The maximum length of the nickname should be 32, etc. So all of these are the parameters that you can customize. So you're going to tell your blockchain that these are the parameters, and this is the file where you mention to your blockchain that these are the parameters. So before we go any further, let's try to check if all the dependencies are taken care of. I'm gonna copy the code that I have right there. So I hope everybody is able to follow me so far. Yeah, so here is where the package manager is trying to check if adding Nix palette, did it introduce any dependencies? if it did, it's going to import all of that and then make sure everything works well. All right. So I'm going to let it run and go back and copy this code. Okay, so if you navigated to runtime source folder, so lib.rs is the file where all the core blockchain logic runtime logic is specified. So I'm going to go there and then make the changes. So runtime source lib.rs. Fine. So I have, all the parameters that it is using. And every palette that we included, it has like a runtime logic that is initialized here. So what I'm going to do is I'll quickly go to the balances palette. You can copy this over anywhere. I'm just copying it here for, just going to remove. Yeah. So all I did was I copied over the code that tells all the parameters right here. And the other thing is I've introduced this new palette into the runtime, right? So I should ask Substrate to put this together in the runtime. So that's where the next part comes in. So let me talk about this one. So construct runtime. So now that I want to include a new set of logic into my runtime, so I should tell the Substrate core logic to include this into the runtime. So let me copy this over. Don't copy this over. So it's only one line that you have to copy over. Okay, so this is the line, and where you should copy it to the construct runtime macro you have in the code. I'm just going to go back and let's see where that construct runtime is. It should be, I'm going to use search button if I don't find it sooner. But yeah, construct. Okay, there it is. So here, all of these palettes are included in an order. Okay, so let's add it right there. And so we're all set. I'm just going to save it. Let me confirm if anything else has to be done. Nothing. So we just build this now. Okay, so this is going to take some time. And I don't know if people will be able to ask questions to me, but when this compiles, I think I should be able to take those questions. Okay, so we're almost at the end of the workshop, and let me go back and then make sure every file is saved, and now it's going to build. At this time, I'm open to ask questions on whatever is happening so far. I don't know how you would like to administer that.
Well, that was indeed a very insightful session. Thank you so much, Radhakrishna, for enlightening us with your knowledge. So now we shall proceed towards the questions from our enthusiastic listeners. So we have here a few questions in the chat. Lakshay has asked, what are the basic requirements for a budding blockchain developer?
So one thing, I entered the blockchain space when 6 months back. Like you mentioned earlier, that I was a teaching professor at University of Vermont. I've been teaching courses pertaining to Python and Java. So if you're a programmer, you should be able to pick up everything that's happening in the blockchain space. And again, everything is new. You'll hear a lot of catchphrases and words. the ecosystem that I am in uses like Rust. So Rust programming language is a starting point, especially if you want to get into like Polkadot ecosystem. You don't have to know everything about Rust, know the basics, and then see Substrate, how Substrate is using it, right? So, so that is my advice. Like I'm pretty new to the space too, and and I picked up like Rust, and then I ended up in the Polkadot ecosystem.
All right. So another question from Price: how it is different from Ganache blockchain?
Once again, my focus has always been on like Polkadot. I'll be able to answer that if I, do that comparison. I'm happy to share it like later on in Discord.
All right. So another question from Anant: is Polkadot like Truffle framework or it is like MetaMask?
So MetaMask is more like a wallet, right? So again, like Polkadot is a layer 0 blockchain. So we are talking about, so if Google, Facebook, all of these are layer ones, we are talking about the internet itself, the internet through which like I'm, talking to you right now. So it is the base layer that is going to facilitate all of these layer 1 blockchains talk to each other. Okay. Yeah.
Okay. So let me see if there are any other questions. Pankaj has asked, what happens if you want to go on a previous version of the block? How do you manage the legacy code?
Oh, yeah, that's a really good question. So like I mentioned, every block, so in Polkadot, every block has the runtime logic, the state transition function on the block itself. So if a validator has to create a block, they need not look anywhere else for code. So they'll just fetch that from the block itself and then run it. And that code can also have like an upgrade uh, associated with it. So from then on, like the code, that blob itself is updated, and any sort of new transactions will have to go through that upgraded runtime logic. Now, the question is, how do you revert it back to like previous thing? So let's say this runtime upgrade ran into a huge, uh, you know, a bug, and then you want to revert to the older one. That can be again like pushed or reverted through governance. So so governance palette has, you set the parameters. You'll say, okay, this didn't work, just let's just revert back to the previous thing, and you'll be reverting it back that way, making any sort of changes that are required, and doing the cleanup with whatever blocks have already been produced. Yeah.
All right.
So let's see how the node is doing. It's almost getting
Yeah.
compiled. So I just have this last 2 minutes. Once the node is compiled, I'm going to show you quickly how to add nicknames to the accounts on the blockchain and interact with it.
So
So
we have another question. Do
yeah, I see that.
blockchain projects needs a backend?
Yeah, so the backend is basically the node, right? So blockchain is not living in a central location. Earlier, I showed you on the telemetry all the nodes that you see globally, for Polkadot at least. So that is where the blockchain lives. And you can go to the Polkadot repo, create a full node. It runs on any machine. So the blockchain exists on your machine. And you might ask, like, Polkadot has like 7 million blocks. Is it downloading all those blocks on my machine? So the answer is no. So it only downloads the last around like 84 blocks, because everything in the blockchain is finalized. If it needs some information from a block behind that one, it's going to make a query through RPC, and then get that block and then do the processing. So yeah, so the backend can be your computer. So you can just spin up a Polkadot node, and you should be able to communicate with it.
All right.
Yeah, it's almost there. Can we like wait for like few more minutes? Is that okay?
Yeah, sure, we can.
Okay, yeah. So I'm gonna reshare the screen. And really good questions, and I'll be available on Discord. I'll be able to answer the questions in depth there. All right. So for those of you who were following me, probably you were at the same, you know, location as me. So what happened here was, if you look at all the logs that were there when it's compiling, so you can see how many modules or palettes have been added when compiling this node, right? So feel free to make a note of all of those, observe like what kind of libraries are required for a substrate node to function. So once like this compiles, we should be able to where is this? Yeah. In the interest of time, I'm going to show you exactly how to interact with the new palette that you added.
Sorry to interrupt you, Radhakrishna. Your screen is not shared.
Okay, so I'm going to share. Okay. Yeah, while this is compiling, I'm going to show there. So right after it is compiled, you should be able to connect to the blockchain node using this command. Go to the Polkadot.js, and in the extrinsics, you should be seeing a new palette added, which is Nix. So it gives you a bunch of like options to set a nickname, clear a nickname, etc. And feel free to like play around with it, and so I'm happy to answer the questions like later on. But yeah, so this is something that I anticipated. Compiling a whole node does take some time. Meanwhile, happy to answer any further questions.
Yeah, let me check if there are any. So we have one from Chris. How do you see hackathon? How do you see blockchain influencing the future?
Oh, it's already started its influence, right? So let me get back to the screen just a second. Yeah, so I myself, I'm very excited with the prospects that come with the blockchain. So, so what is blockchain, right? So everything is final. Like once it gets to the block, nobody can change it, and that gives a lot of power. Uh, so every time we look at the history, we see that people tend to twist things and change things to the way that they want things to be. That's not possible with blockchain. Okay, so that comes with a lot of power and a lot of influence too. And not every problem can be solved with blockchain, let me be clear, but there are few problems which blockchain can solve very efficiently. But yeah, so there's a lot of future in terms of anything you want to be like final, like let's say government like selling some land or whatever. So those papers, they can be forged with what we have, what technology we have, but putting that on blockchain, that creates only a single instance, and you can be pretty sure that it's there. So medical records, privacy preserving applications, plenty of them. And currency is only one thing. Okay, so Bitcoin, it started with Bitcoin, but yeah, blockchain is expanding to a lot of other fields too.
All right. Maverick has asked, how did you start your journey in this domain?
Yeah. Yeah, I mean, it was hard to ignore like happenings in blockchain when I was finishing my PhD in computer science. Yeah, so and I used to hear a lot about like Bitcoin, like Ethereum, and all the applications you're building with it. So it started like last year. So I was looking at like what's happening in the field of Ethereum, and that's when I've noticed like people are actually working on like eliminating the issues that are boggling Ethereum, and that's when I got into like Polkadot ecosystem. So Polkadot, the network architecture. I don't know if you all know Gavin Wood, who started like Polkadot. was also a CTO of Ethereum, like one of the co-founders. So coming from him, I've seen his perspective as to how to scale a blockchain in a way. Uh, I was very fascinated by that, and then I've seen that there is a scope for me to join the team, like as a technical educator. So I just used that opportunity and then jumped in here, and that's where I ended up. Yeah, but yeah, so I think the main thing that inspired me to get into blockchain is uh, the way the existing financial system like works, right? So there's a lot of dependence on middlemen and banks. So that shouldn't be a hurdle for economic prosperity. So I feel like blockchain offering a trustless solution where you don't need intermediaries when you're interacting with others, especially when you're putting a lot of work. You want to earn what your work is rather than somebody taking a pie of that. Yeah. So that started the journey into this.
That's great. So we don't have any more questions.
Yep. It looks like the the cloud instance gave up on this one. I'm gonna wait for 1 more minute and then we can call it a day.
Yeah, sure.
Okay. I'm gonna share just in case. Perfect. So we're here. Hope everybody is able to see my screen. I'm just gonna,
Yeah, it's visible.
yep, just gonna close off today's session by showing you, no, not this command. Perfect. So let me go to Polkadot.js apps. Okay, so developer extrinsics. So in here, you would see that Nix palette is added. And what did we do to do this? We just added a dependency. We just added the parameters that were required, and that's it. So Nix, and I'm going to set a new name. So I'm going to set this with my nickname, which is Radha, and I try to submit this transaction. So this is going to be a failure because I showed you the minimum number of characters required are 8. So this thing only has like 5. So I'm just gonna add like more characters and then sign and submit the transaction. Because I have the sudo access, I should be able to submit any transaction on behalf of any account on the blockchain. So let's do that. There you go. So the transaction is a success. And from now on, like the account Bob is called Radhakrishna. So you can feel free to explore like all the functionalities offered by Nix palette, see how things are changing. So if you want to like check how the balances palette work, you can always like send money from one account to the other. So for instance, from Alice to Ferdy, I'm gonna send like 10 probably, and then make transfer and then submit. And then once this is finished, like you'll see the transaction going. So the whole point I'm trying to make is if you're a developer and then you're trying to get into like developing blockchain applications, you have Substrate, which is modular extensible framework, and like you see, everything was done on a browser. It's offering such flexibility for you. So I'm not saying you have to do something for this hackathon, but in the future, keep this as an option. Check it out, and you'll find it definitely very handy if you're developing blockchain applications. Thank you.
All right. Well, that was indeed a very insightful session. Thank you so much, Radhakrishna, for enlightening us with your knowledge. And it was really good to seek all the information from you. And I'm sure the audience agrees with me.
Thank you.
Thanks a lot.
Yeah, thank you.
So, guys, you can fill out the feedback form and let us know how you like the session. Feedback form is there in the description. Sorry, in the chat box. I would like to thanks to our very patient audience. We hope you were enlightened and will make full use of all the knowledge imparted today at the time of the hackathon. So this was just the start of our amazing lineup of sessions. There is much more to come, guys. To know more about what we have in store for all of you this time, do not forget to join our Discord server where all the announcements related to hackathon will be posted. And check out our website hackcbs.tech for the lineup of all the wonderful sessions. The link of our Discord server and the website is dropped in the description for all of you to visit and register. We surely don't want you to miss out on the amazing swags delivered at your doorstep and prizes worth $50,000. So we are just left with 3 days to go until our registrations ends. So hurry up now and grab your boarding pass for the 4th edition of India's largest student-run hackathon, hackCBS 4.0. Also, we are having our next workshop at 5 p.m. tomorrow on 3D printing and how it's literally shaping our future by Aryan Chaudhary. So do set up your alarms for this session and hope to see you all there too. Thanks a lot.